Bonjour tout le monde. Hi everyone, and welcome to today's webinar, What's New on ClimateData.ca. My name is Sarah Rayfield, and I'll be moderating today's webinar. I'm the Manager for Service Delivery with the Canadian Centre for Climate Services. Our mission at the Centre is to provide Canadians with information and support to consider climate change in their decisions. And we're here to help people find and understand climate data and information and offer a range of services, including a support desk where you can contact us with your specific questions. Most of you are listening to the webinar directly through your computer speakers. However, if you run into any audio issues, you can also call into the conference line. You can find the conference line number and participant code in the box under Message to the Host or in the webinar reminder email sent earlier today. We've muted your computer mics to avoid any audio distraction or feedback during the webinar. We'll have a dedicated question and answer session at the end of the webinar, but that doesn't mean that you have to hold on to your questions until then. Please feel free to type out your questions during the presentation into the chat box area on your left. The presentation will be in English, but you're welcome to ask questions in the official language of your choice. We're going to be recording the webinar today, and we'll send a link to everyone who's registered. If you run into any audio or technical issues during the webinar, please hover your mouse over Suzanne Feeling, so Suzanne, S-E-I-L-I-N-G, name, on the attendee list under Host and click on Start a Private Chat, and she can give you a hand. Before we launch into the session today, it would be really great to have a sense of who we have joining us today and how familiar you are with ClimateData.ca. So these questions are totally voluntary, but it would be great to have a sense of who we have joining us. So please take a moment and let us know. Great, thank you very much. We've got a nice diversity on the line today. Really great. The next question I'd like to just is get a baseline of how familiar you guys currently are with ClimateData.ca. Okay, great. So some familiarity, for some it's quite new. Okay, so we have a bit of a mix. That's great. Super, thanks for doing that. So now I'd like to introduce our speakers for today's webinar, Elaine and Katie. Elaine Barrow has been a Senior Climate Advisor with the Canadian Centre for Climate Services since February 2019. She's involved in the development of ClimateData.ca and of training materials to help decision makers understand how to use climate information. Katie Pearson is a Policy Advisor with the Centre. She recently joined the service delivery team and has over a decade of experience in public service, developing and delivering environmental programming and initiatives to help raise awareness and foster positive change. On behalf of everyone joining us today, I'd like to extend a very warm welcome to Elaine and Katie and to thank them for providing this webinar for us today. Without further ado, I'll now turn things over to Elaine.
Okay, so hopefully you can all see the ClimateData.ca homepage. So yes, thanks Sarah. So today basically what we want to do is provide a quick overview of ClimateData.ca. We're going to focus on two new features that we have, the Analyze page and the Learning Zone. But first of all, I'm just going to walk everybody through the website as it is at the moment, just to give you a quick overview, quick reminder of what features we have, what data we have available. So first of all, just to remind you that ClimateData.ca is a partnership between Environment and Climate Change Canada and our regional climate service providers, so URANOS in Quebec, the Pacific Climate Impact Consortium in British Columbia, and the Prairie Climate Centre, which is headquartered in Winnipeg. Our sort of site design, development, and all the computing resources are provided by the Centre de Recherche Informatique de Montréal and Habitat 7. And we've been working together probably for a couple of years now on ClimateData.ca. So the mission of ClimateData.ca is basically to provide high-resolution climate data to decision makers to help them build a more resilient Canada. And we're doing this by providing climate projections and also observe climate data. We basically have 4 ways where you can access climate information: search by location. We have a menu bar along the top and also a quick start menu down the side. So search by location, by variable, by sector, or through the download option. So I'll just quickly go through these different features just so that you're familiar with what we have available. So location page, I'm based in the prairies, so I'll just put in my local site, so Regina. The first thing that you will see is a summary of how climate has changed, so temperature and precipitation have changed, and also projections for the future based on a high emission scenario, just in this red box here. And then as we scroll down, you can see that the data are organized in categories. So we have the temperature variables first of all, followed by precipitation variables, and finally other variables. And these are what we're showing under the location page are the annual values. So if we click on temperature, you see we've got a list of variables in this category. If we simply choose mean temperature, and we see a time series graph that appears underneath. Basically, all of the information that you're seeing on this graph is from climate model simulations. We have what we sort of call by shorthand the BCC AQV2 data set, which is our downscaled and bias-corrected data set, and it consists of 24 different climate models which have taken part in the 5th phase of the coupled model intercomparison project. And we have within these, for each of these models, we have 3 different emission scenarios, the representative concentration pathways. So we have a low scenario, the blue one here, which is RCP 2.6, a moderate emission scenario, RCP 4.5 in green, and the high emission scenario, RCP 8.5 in red. And using the bar along the top, you can take any one of these emission scenarios. You can click them on or off so you can see if you want to focus in on a particular one without seeing the, with them all being sort of rather overlaying on each other, you can use that menu at the top. This part of the graph is the model simulations over the historical period. So each model also simulates climate over the historical period. They start in about 1850. We show them from 1950 as we have bias corrected and downscaled this data set. And in order to do that, we need to have an observed, a good gridded observed climatology, and that's not available in Canada till about 1950. And you can look at what the values are for this gridded historical data set, which we call the Annuslin data set, and overlay them by clicking on the button up here. And what we're looking for here is not looking to see that the sequencing is exactly the same, but we're just looking to see that the observed data set is within the range or not very far outside of the range of our model data set. So that's our location page. If at any time you want more explanation of this graph, simply click on the How to Read This button, and it gives you an explanation of exactly what you're seeing. And obviously, as you move your mouse across, you can see the median values for these scenarios in the bold, and then the range, which is represented by the 10th and 90th percentiles by the shaded area. You can download this data from here by clicking on this little hamburger menu, or you can download the images as well. And if you just want to go straight to looking at the map, if you click on the View on the Map button on the right-hand side here, that will take you to the map page, which we will now look at by going through using the variable option. So here we have a number of quick links to the sort of most widely used data sets, and also View All Variables, which if you click on here, you'll get the complete list of climate variables and indices that we have available on ClimateData.ca, but also under this section you also can access the Meteorological Service of Canada climate normals for the 1981 to 2010 period, and also IDF curves, intensity, duration, frequency curves, also from Meteorological Service of Canada for the historical, over the historical period too. So if we just click on any one of these variables, mean temperature, for example, the first thing you need to do is select which emission scenario you want to view. So if we leave it at the high emission scenario, RCP 8.5, click on Explore, and we get taken through to the map of Canada. We have this, if you're not familiar with ClimateData.ca, this little how to use this page box takes you through explaining the different options that you see on the map, which I will show to you now. I'm just going to come out a little bit so we can see the whole country. The slider along the bottom, you can move through time and see how mean temperature changes out into the future. You can also use the opacity slider here just to bring forward the geographical features on the map if you wish to do that. You can change the variable just by clicking on the mean temperature button here. It gives you the list of variables available. You can change from looking at the annual timescale to look at any particular month, say July for example. And also you can change your emissions scenario here. So you can look at the individual emissions scenarios or you can compare them. So for example, we can plot RCP 8.5 versus RCP 2.6 and you see them side by side, so you can see the differences between the projected warming for each of the scenarios. I'm just going to go back to the single emissions scenario. You can zoom in from this point into the map. I'm just going to bring us back down to southern Canada. And you'll see the grid boxes appear. And if you click on any of these grid boxes, you end up with the time series graph very much as if you had used the search by location feature. Okay. The other option is to look by sector. At the moment we just have the health sector available. We are almost ready to launch the agriculture sector. We're in the last stages of doing all the testing and checking of data and everything which is going to be provided for that module. So hopefully in the next couple of weeks you'll see some changes to ClimateData.ca. But the idea of the sector modules is to provide more information to users within these particular sectors. So we provide examples of how climate data has been used through a number of different case studies. And we also provide data, in this case by health region. This is what was requested by users in this particular sector. And the very first sort of thing that we do when we design a sector module is we have user engagement with that particular community, and this is documented under health sector methods here. So the things that came out from our user engagement in this case was that this particular sector really needed data organized by health region, and this is what you see here. Actually, let me just come out. So these are all the different regions, health regions in Canada. We are actually improving our northern health regions. We have some new shapefiles that will be added in there. And you just simply click on one of these regions and you get the data organized for that region. So it's been averaged over that particular region. And as I mentioned, we have a number of case studies. So we have, in this case, they're categorized into 3 different categories. Emergency measures is the first one, where we look at extreme heat waves, and we have a case study that looks at extreme heat waves in Quebec, and we have the climate variables that are most related to that particular case study. So you can easily find the information that you might need. Let's just go. Okay. We have health infrastructure, which looks at BC hospitals actually in the design, obviously, as well as climate change impacting people's health. It also impacts our infrastructure. So this talks about changes that might need to be made to hospitals in terms of providing more air conditioning, things like that. And our final one is public health, and we have a couple of case studies under this one which looks at physical and mental health impacts in New Brunswick, and then also one on Lyme disease in Ontario. And then the last way of getting data from ClimateData.ca is the download section, and here we have a number of options. So first of all, if we're looking at our climate projections, this is our BCCA QV2 data set. You can either download, well, you can download as a number of different spatial temporal resolutions, sorry. So we have annual, daily, and then the monthly values. If you select annual, you'll see the whole range of variables that we have available, all the climate indices that have been calculated. If you simply select daily, then you basically get the three data sets that underlie all of the information that you see here, our minimum, maximum, and total preset data sets. So once you've selected your data set, the time resolution that you're interested in, the variable that you're interested in, you then have to select your grid box. So you can search right here, and then you can select single or multiple grid boxes, and the data will be provided to you. You can select your data format. As I've selected one of the annual indices, it's available in comma-separated values or JSON format, and you simply have to type in a file name and select process, and it will do that for you, and the data will be sent to you CSV in a file that's very easily opened in Microsoft Excel. If you select a daily data set, then it will be processed and sent to you. It's more data, and it's a bit more of a detailed process. So here again, you select your format. Now you've got the option of NetCDF, which is basically used mostly by climate scientists, people who are used to working with codes and programs and big data sets, or CSV. You enter the characters, put in your email address. If it goes through, the request goes through successfully, it will say it's been submitted successfully, and then you'll get an email when the data are ready, and the email will contain a link to the data set that you've asked for. Here you can also access the Environment and Climate Change Canada's station data catalogue, and you can either do it, but if you know the station names, you can type them in here, or you can select on the map. Just by zooming in, it makes it more legible, and you can just pick any one of these, and it will give you the whole observed record. 1840 is the earliest start date, I think, for any of the observations in Canada, and it goes through right to present day. And again, you can select the format that you want, put in a file name, and it will process the data. You can do multiple stations. You don't have to limit yourself to single stations. It will do multiple stations at any one time as well, and you'll see them added up here. And then finally, in the download section, you have access to the Meteorological Service of Canada's IDF curves. And this is a very similar thing. You select location that you're interested in, and you can then see graphics of the IDF curves. So, and it will download for you. So, but what I wanted to show you today is our Analyze page, and basically this came out of conversations that we had at ClimateData.ca in response to questions that come into our service desk, where people are asking our support desk for climate information. And basically what we decided to do was to create this functionality so users could do some of this analysis themselves if they want something that's slightly different from what we provide on the main pages, or they want to specify their own thresholds, for example, for a heat wave, which obviously the thresholds for a heat wave vary across Canada, and what's a hot day in the north, in Canada's north, is not necessarily a hot day elsewhere in Canada. So we came up with this functionality. The first step of which is choosing the data set. At the moment, we have simply the BCCA QV2 data set, so our bias-corrected and downscaled data set. We will potentially be adding other data sets as obviously as new climate projections become available, they'll be added here, but we're also talking about doing a station data analysis page as well, which we're hoping to add. It will be some time. It won't be in the near future, but that's an addition that we want to add. So you select the data set that you're interested in. You then have to select your location. And likewise, at the moment we just have grids. So this is basically the 10-kilometer grid that we use with BCCA QV2. But we will be adding, for example, the health regions. They will be added to this option here. We also have watersheds and census regions that will be added shortly to this option as well. So for the moment, we just have the grid option available. So we select our location. Again, you can type into the box and select, and it will zoom in. And you can select here a single or several grid boxes. And then the next stage is to decide on which variable that you want to provide your own threshold for. So we have quite a range of different variables that we've selected here as being the ones that are probably most likely that people want to have their own threshold. So we have wet days, where you simply have to define the threshold for which you want a day to be considered wet or dry, and you input that in the blue box here. Average wet day precipitation intensity, so the average amount of precipitation that occurs on wet days using the threshold that you're interested in. Maximum consecutive wet days, maximum consecutive dry days, and days with Tmax and Tmin, so maximum minimum temperature above specific thresholds, which you enter here. Days with maximum temperature above a specific threshold, similarly for Tmin, and also we provide days below a minimum temperature threshold as well as an option. We also have degree days here, so degree days above, degree days below. So for example, if you wanted to use a different threshold for calculating cooling degree days, the sort of standard threshold for that is 18 degrees Celsius. If you wanted to use a different threshold, you can do that. Similarly, growing degree days fall into this category here. So if you're interested in an agricultural application, whether it's a specific crop or it's a crop pest that's development is dependent on a specific threshold temperature and a number of degree days being reached above that threshold temperature, this is the variable that you would use. Degree days below a specific threshold, similarly, the same thing. And then we have a number of different heat wave variables, so the simplest of which is simply a number of consecutive days where maximum temperature is above a specific threshold. Then more complicated is heat wave total duration. In this case, you're looking at an event defined by both minimum and maximum temperature, so you'd put in a threshold value that you want to be exceeded for minimum temperature, and similarly a threshold value for maximum temperature, and you define a number of consecutive days that you want the heat wave to continue over. And so this analysis will give you the total number of days in heat wave events by year. If you want to look at heat wave frequency, then this gives you the number of heat waves. So you define your event in very similar ways to this previous index, but it will tell you the number of events that happen rather than the total number of heat wave days. And then finally, the last two, we've got days with a freeze-thaw cycle where you can define the daily max and daily minimum temperature thresholds. Just looking through the literature, these thresholds vary quite a bit, so we decided that this was also another index that would be useful for people to allow them to put in their own threshold values. And then finally cold spell days, so number of days, consecutive days where mean daily temperature is below a specific threshold. So I'm just going to fill in the heat waves frequency one and ask for data to be analysed where minimum temperature is greater than 20 degrees Celsius, where maximum temperature is greater than 30, and for a minimum of 3 consecutive days. And don't forget to fill in the numbers. I've done that before. You sort of select your index, and then you forget that you have to put the threshold values in. Next step is to choose a time frame over which you want the analysis to happen. So the start of our time period is 1950, and you can go right up to the end, which is 2100, or you can choose any time period in between. And then finally we have an advanced section, and here we allow you to select a different set of models, to select different RCPs, and also to control the percentiles that you want to use to analyze the data. So all models is our set of 24, which are in BCCA QV2. PKIC 12, as this subset has become known, is a subset of 12 climate models, which are all part of the 24. And the Pacific Climate Impact Consortium did some work analyzing these models, and they found that this particular 12 in this data set captured the range of projections of future climate change, and not just looking at the range of the mean, but also range in the number of different extremes as well. So you can pick either one of these, whether you want the 12 or you want the 24. You can change the RCP here, so we'll leave it at 8.5, but you could have 4.5 or 2.6. And then you can also ask for different percentiles to be calculated. What you're getting out of this analysis is the information that would allow you to construct one of the time series graphs which you have seen. So you're not actually getting the raw data here. That's what you would get through the download page. Here you're getting the data analyzed and provided with the percentile values for each year. So our standard percentiles that we use on ClimateData.ca are the 50th, so the median, and then the 10th and 90th percentiles to define the range. There's obviously a couple of models above and a couple of models below our defined range. But you could choose to select the 5th as well, or the 95th, and you can click these off if you don't want these ones. And then you basically select your output format. Here you've got comma-separated values again, and then also NetCDF. If you're used to working with programming languages such as R or Python, you can use NetCDF files. So here you enter the characters just to prove you're not a robot, and then put in your email address, and you should get and send a request. It should come up, a little box should come up and say successfully submitted. If that box doesn't appear, it means that your request hasn't been submitted. So it's best to just go back and check that you filled things in, that you remember to put your threshold values in. And if for some reason it still doesn't work, you can use the feedback button to let people know at ClimateData.ca that you're having problems. Generally, things go through. It says here that it can take 30 to 90 minutes for your data to be processed and for you to be notified that it's available. I think I've never had to wait more than 10 minutes. It obviously depends on how busy the server is, but I've never had to wait more than 10 minutes when I've put in a data request. And then you'll be sent an email, and it will give you a link to the data set that you have requested. And then you can go ahead and use that to construct time series graphs or whatever you want to use it for. And I think that's it for the analysis page. And then finally, I did mention this feedback button. You can use this to report if you have any problems. You can use it to ask questions, and all of those questions go back to the Canadian Centre for Climate Services, to the support desk. and they're dealt with there, whether they get sent on to specific experts, or most of them they manage to answer themselves. And that's it from me, and I'm going to hand over to Katie now to continue.
Elaine, I think we are going to start to give you some questions, actually, because there's a lot of questions coming in related to what you've just toured us through. So I think we'll start with your permission. Is that okay?
So, yes,
okay,
that's
perfect.
fine. Yeah.
So, Katie, we will come to you. We definitely want to show everybody what we've been doing in terms of learning tools with our partners on the site. So we'll get to that, but we'll start to take some questions. So I'll kind of go through the order I have received them in and just read them as they are largely, with a bit of grouping where there's a similar theme. So we have one question, which is it's a comment around some concerns around fossil fuel financing, and a question that says, it seems clear that more data isn't sufficient to enacting change. So how should we as citizens use this data productively?
Well, I think sometimes it's how the data is presented that will help enact change. And one of the things that we want to do at the moment, the focus for ClimateData.ca has really been on making data available. And then the next step, I think, is for people to take that information and put it into formats that make it more accessible to people. So one of the things that we do want to do on ClimateData.ca, but is a little bit further down in our sort of workload, our plans, is to actually interpret this information and show what it's going to mean to people. So instead of giving you, saying, well, by the end of the century you would expect a 2 degrees Celsius increase in temperature, we're actually going to translate that into what it will mean to you, what you'll see that's different. And I'm really a data person, so this would be a question as well that you would want to give to somebody who's more outreach and engagement. But I think certainly having the data available makes it much easier for us to make that next step. And from what one of the reasons that ClimateData.ca was developed was because we were hearing all the time that the access to data was what was the barrier to helping people make decisions and to make change. And so I think we've made some very good steps forward in terms of getting that data available. So now getting it into a format that then is meaningful to people is one of the next steps that we should take.
Thanks, Elaine. The next question relates to seasonal outlook. So is it possible to look at a season, for example, summer, for variables rather than a specific month?
Not at the moment, but it should be coming soon. It's the data has all been processed by season, so it's a question of putting it up by season. We're actually in the middle of doing a very thorough sort of analysis of the next set of changes which are going up onto ClimateData.ca, and I think the seasonal data is part of that. I will have to check, but it's something that will be available soon. And it will be for variables where it's relevant. So some of the indices that we provide are not relevant by season, so you won't see those. But for all the main variables and indices where seasonal information makes sense, that will be available shortly on ClimateData.ca.
All right. There's a question about whether a module or information on the energy sector will be forthcoming or will be coming soon.
We have 2 modules. As I mentioned, the agriculture module will be coming shortly. We're just waiting for all the checking to be done. We have a transportation sector module and we have a buildings module, which should also have some sort of presence on ClimateData.ca by the end of this fiscal year. So those are the next two sectors. Energy is sort of on our radar, but it's not something that we've spent a lot of time talking about as yet, but down the road potentially we will have something for the energy sector.
All right. This one is around, another one that we have is around long-term averages. So long-term averages have less uncertainty and are usually used when talking about climate change. Could you please elaborate on how to make those time series of year-to-year numbers you presented and for what kind of application. So I think it's sort of understanding the time series.
Well, one of the things that is another addition which is coming soon is the 30-year averages. You already see on the map page that when you go through time, you're looking at 30-year averages. We will be adding that to the time series part of so the location part of the page as well, so that you'll be able to see on those graphs, you'll be able to see the different 30-year periods. And we're hoping that we would have like the average values over those 30-year periods available on the visualization. That we're sort of still designing it and talking about how we're going to do that, but that is something that we will be adding at the moment. But at the moment, you would simply be averaging. You'd pick your 30-year period, and you'd have to average the numbers for the 30 years. But that's the way of getting around it at the moment. But I say that functionality will be coming to ClimateData.ca relatively shortly, so it will be added.
Great, yeah, we're looking forward to that addition. There's an interest in watershed level data, so there's a question, can we have access to watershed level data or watershed specific data options?
They will be there. That's what we're checking at the moment, and once the next sort of update is done, watersheds will be available, as will census regions, and you'll be able to select by watershed. So if you remember, I showed you the data by health region. You'll have a similar map, but with all the watersheds on, and then a similar one for the census regions as well.
That's great. So there's a question around: is there a reason that the data displayed actually date only until about 2005? When will this be updated with more current data?
That's a good question. I'm not sure. Like the annual spend data set, I think goes up to about 2015 at the moment. So it's an addition that we can add when we do an update. I'll make a note of that we can add in annual spend. And then obviously when we do an update, the next set of projections which are coming are known as CMIP6, so they're the 6th phase from the coupled model intercomparison project, and there's some differences in the sort of reference data sets and things with those new sets of projections, and we will make sure that we have the relevant observed data for those data sets as well.
I have a couple questions here related to sort of format. So a question about if you don't have Microsoft Excel, can data be made available in Excel format? And about whether there's an API for programmatic access.
APIs are on our list of things to do. That's one of the things that we are talking about as well. If you do have, like you can actually ask the support desk if you want a lot of data, and it would, it's quicker if we prepare it for you than if you try and download it from ClimateData.ca. So that's one way of getting it. But we are talking about APIs, and the simplest format that we provide is comma separated values. So that will go into anything that any sort of piece of software, whether it's Microsoft Excel or it's something, I'm just trying to think of something else, so something like S+ or something like that for doing statistics. They should recognize comma separated values, and the data should easily import into those applications.
Great, thank you. I have a couple questions related to IDF curves. So there's two. So one is, have IDF curves been projected to grids as well? Or are they available only at station point locations, the station data? The second one was, are the IDF curves corrected for future projections using any particular RCP?
The IDF curves are per point projections. They're not a gridded data set. They're basically just the location that it was recorded at, and that will continue. We will be providing guidance soon for how to update an IDF curve to take into account future projections, but that's it's the sort of guidance that we're working on at the moment, and it will come at some point. I would say probably by the end of the fiscal year, but it's a very it's very on the edge of science, sort of climate science as we know at the moment. There's a lot of things you need to know about extreme precipitation. There's a lot of things we need to know about climate modeling when it comes to modeling extreme precipitation. So it's not a simple thing to do, and we want to make sure that we get the correct guidance and potentially provide some functionality so it would make it easy to update the existing historical IDF curves with climate change projections. That's something that we're working on.
Great. Thanks, Elaine. So there's questions around whether data is bias corrected. So the daily data for download, is it raw climate model data or bias corrected? And then if the climate data is bias corrected, is it based on gridded NRCan data or Environment and Climate Change Canada station data?
The bias correction is, I've forgotten the first part of the question. The data that you download, yes, all the model data is bias corrected, so you're getting a bias corrected daily data set. The data set that has been used to bias correct those models is the Annuslin data set from Dan McKenney's group, and that Annuslin data set is an NRCan data set, but it's using Environment and Climate Change Canada's station data set to construct a gridded historical climatology and daily climatology. So it uses Environment and Climate Change Canada's station data set, but it's an NRCan product.
Okay, perfect. Thank you. We have a few more questions that we want to get to, and we will do our best to get to, but I'd like to turn it now to Katie Pearson to talk to us and to share some information with everybody about the learning tools that are available on the site. Katie?
Thanks, Sarah. I am really excited to say that ClimateData.ca has a new learning zone, which we launched at the the end of October, so it's new to the website. Before I jump to that page, I just want to bring our attention to the fact that this page is available and all of the resources will be available in both French and English, so you can toggle between the two languages in the upper right-hand corner here between EN and FR. So how to access the site? There is a Learn link at the top of every page, and if you scroll all the way down to the bottom, at the bottom of each page there's also a Learning Zone link. So that's two ways that you can get to the site. From the landing page at ClimateData.ca, you can also access the Learning Zone with our Quick Start link here on the right-hand side, or by clicking on the yellow text here where it says click here to learn more. So I'll use this top link and switch over to the Learning Zone. So welcome to our Learning Zone. This, as I said, was added at the end of October, and the aim is to help support users of the site to learn about the science behind climate data and how to access that data on ClimateData.ca. The learning resources were created in collaboration with URANOS, the Pacific Climate Impacts Consortium, the Prairie Adaptation Research Collaborative, and the Centre de Recherche Informatique de Montréal. Currently, the content on the Learning Zone is at an introductory level, and it's organized by topic. So you can see those topics here in the quick links. So Introduction to Climate Information for Decision Making, Understanding Historical Data, How to Use ClimateData.ca, and Training Materials. These topics and resources can also be filtered by video, interactive, and article. So if you click on video, you'll see that everything that isn't a video will be grayed out, and just the videos will be left. Each resource has a title, a quick summary of what you can expect to see, and an icon to let you know what type of format it is, and a time to completion. So before we move on, maybe we'll take a moment here just to watch one of the videos. So I'll stop sharing my screen so that we can watch a video.
Introduction to Decision-Making Using Climate Scenarios. As our climate continues to change, we need to make decisions and design for an uncertain future. Climate projections based on a variety of scenarios can help in that process. A scenario is a postulated course of events. It is not a prediction. Scenarios are used in a wide variety of planning activities, from infrastructure design to healthcare, because they enable planners to consider a range of possible futures and minimize risk. For the same reasons, emission scenarios are used in climate models. The 3 RCPs, representative concentration pathways, illustrate 3 levels of warming and their impacts. Comparing impacts from the lowest and highest of these helps us understand the choices that will determine our future. Choosing what emissions scenarios to examine depends on a variety of factors. In many situations, it makes sense to stress test a system by looking at the highest plausible scenario. As experience with various crises demonstrates, preparing for low probability, high impact, worst case scenarios is just smart planning. For any questions about using climate data and information, please contact the Canadian Centre for Climate Services Support Desk.
Great. So now I'll share my screen again. And so for each of these resources for the videos, you'll see that they will include a script. So if you wanted to know what was happening in the video without watching it, there's a transcript here of what's happening in the video. For articles, it would include a summary as well as the article itself. So these resources will continue to be developed, and they're user-driven. So this first batch of resources, they were prioritized based on user feedback received in sessions like this one today, through collaborating organizations and through our support desk. So the user needs analysis is ongoing and will continue to drive our future products. If you have any suggestions of content you'd like to see, you can let us know in the survey following this session, or like Elaine was mentioning earlier, if you use the feedback functionality here, you can let us know either the online support or the data support, either or, whatever you think is the best fit. Provide your name, email, and what content you think would be helpful to have added. Before moving into the question period, there's one more resource that I'd like to show, and if you are familiar with ClimateData.ca, you may have seen this one before. So in addition to resources about climate data and how to find and access data on the site, we also have training materials. So if you're doing a session like today, there is a presentation that you can download, including the speaking notes. This presentation, to download, all you have to do is click on that button and agree to a few things. One is that you would make this presentation freely available, that if anybody was interested in using this training, that you would redirect them back to this website to download the original, and that you're more than welcome to make any changes to the slides in terms of adding slides, removing slides. If you'd like to change the font and color, change the formatting so that it can align better with your own branding, you're welcome to do that. We just ask that the content on the slides themselves isn't changed. And then lastly, if you're interested in being contacted when we update these slides from time to time, if you provide your full name and email address and accept to download, we will be in contact if and when we make changes to that presentation. So that sums up the Learning Zone. So I'll hand things back to Sarah if there are any other questions.
Thanks so much, Katie and Elaine. We do have some more questions, so thanks everybody. Really appreciate the active chat and questions that are coming in from all over the country. We'll do as many as we can have time for. So this question is from Niagara, Ontario. So it says, where there's a residential development that is approaching draft approval stage. How appropriate and up-to-date are the engineering plans for stormwater management likely to be? And what are the current guidelines for this planning? So this question, I think, is sort of a broader one in terms of a particular residential development. And this person is interested, if I understand right, in understanding how current maybe the information might be that would be relevant for stormwater management.
This is a little bit outside my area of expertise. I do know that there are updates coming to the National Building Code, which are being worked on at the moment, and I think they're due for release. It will be, I think it's for the next 5 years. I'm not 100% sure, but there are updates coming to the National Building Code, and I'm not quite sure when the previous update was done, so it's really quite outside my area of expertise. I would say that potentially the current information is probably slightly out of date, but the newer building code that's coming out, I think, does include information about incorporating climate change, but really outside of my area of expertise. I'm sorry.
We can always follow up with you for this person who's asked this question with a bit more information. You can contact our support desk and we can try to find out more for you. Another question is about estimating storm design for return period. So this person says, I was looking for estimating design storm for a return period of interest, for example, 500 years, by using the 3 percentiles, the 10, 50, 90 climate projections. Please advise on how to consider these 3 percentile data sets to calculate mean and standard deviation that represent the overall projections of the 3 percentiles.
I think that's something that we would have to discuss offline, actually. I would sort of slightly out of my area of expertise as well, the storm design.
Yeah, and we did get a couple of questions on sort of IDF curve and that type of information. This one coming from Lakshman, we can follow up, Lakshman, with you and see whether there's any other information or whether we can connect you with someone who might be able to advise or give you some information there. The next question is related to RCP, so the representative concentration pathways, which you see used throughout ClimateData.ca that Elaine talked about, from the low, medium through the high. So this one says, how likely is RCP 8.5 now, assuming some climate action from most countries?
We're always told that we should consider all of the different RCPs to be equally likely. Obviously, some are, when you look at them, some are more likely than others. RCP 8.5 really does, it's really one of the highest, almost like it's not necessarily worst case, but it's getting to be a worst case scenario where you're assuming that there's a lot of coal burning, there's a lot of, if it's high economic growth, it's based on a lot of fossil fuel burning, or if it's high population growth, it's using a lot of fossil fuels. And I would say that it's something, we're not on that route at the moment. Bringing in some of the climate policy that has been signed by the different countries hopefully will make it much less likely, but in terms of the likelihood at the moment, I think we're somewhere on a path between RCP 6, which we actually don't provide on ClimateData.ca because very few models have actually used that particular emission scenario. I think we're somewhere between somewhere around 6, I think, but this is outside of my area of expertise. So if you look, if you do actually the Carbon Brief has some very good articles on the different RCPs, and so that would give you a lot of background about where we are on the pathways at the moment.
Thank you, Elaine. We have more questions coming in. We, in all likelihood, won't be able to get to all of them, unfortunately, but we'll follow up. You can send your questions on to either the email address that you're seeing on the screen or to Suzanne, who's organized this event. We'll take a couple more. So the next one is, do you have any plans to expand data coverage to include interjurisdictional basins between Canada and the U.S.?
We would really like to, but it's a lot of work, and there's a lot of things that we have to have basically we need an international data set which is consistent across the border, and that means that we have to have, in order to produce a bias-corrected and downscaled data set, we need a North American historical climatology, which I think NRCan Dan McKenney's group is working on, but it's something that if we do it, it will be with the CMIP6. It won't be. We wouldn't go back to CMIP5 and work with what we're already producing, but potentially in the future. And I know there's interest from the US side that we also have. There is a consistent data set across the border. So hopefully at some point in the future, but there's a lot of thinking that has to go into it, and a lot of looking at data and data sets and which are most appropriate, which are best for the type of work we want to do with them. So it is on our radar. When it would be available, I don't know, but we're certainly thinking about it.
Thanks, Elaine. I think we'll be able to take maybe one or two more questions maximum. One that we received was, are there any plans to translate working glossaries of terminologies into Indigenous languages? And we received, that's a question that I'll turn to you, Elaine. And also, there was a similar question related to links to Indigenous communities that came in before the webinar. So we received a question, will any links be provided to Indigenous communities and adaptation projects using climate data from the ClimateData.ca portal? So Elaine, would you have a comment or some information on that?
Sure. Some of the Indigenous communities are available through our location page. We use an NRCan data set to provide all the community names and towns and cities, whatever, across Canada, and there are some Indigenous communities in that data set, so some are available. I know I've looked for others and they're not there, so it is something we're talking about updating. In terms of translating the glossary, that's something that we haven't thought about, but I can take that to the ClimateData.ca team, and we can have discussions about what we can do.
And I could add as well that our partners at the Prairie Climate Center are working with national Indigenous organizations currently to create a map layer that would include the locations of First Nations, Métis, and Inuit treaty and traditional lands. And once that is, their intention is to have that completed in early 2021, and we would hope to be able to use that in the context of ClimateData.ca. There's also, CCCS is also collaborating with NRCan and other federal organizations to develop a database of on-the-ground adaptation actions and case studies and an interactive map, and very much hoping to be able to include Indigenous-led adaptation projects. And that's planning to have a first release in winter 2021. So, and that will be housed on the ClimateData.ca site. I think that we're virtually out of time, so I will just will wrap us up. There are some questions that we haven't been able to get to. Thank you. Merci pour toutes les questions. If we didn't get your question, if we didn't get to answer your question, or if something comes to mind after, you can either email us at the email address you can see up on your screen, or you could email Suzanne. I'd like to thank everyone for joining us today. Really hope that you enjoyed it. It was fun for us to do it with you and to hear your questions. And I just would like to also thank Suzanne for her support in setting this up. And a very big thank you to Elaine and to Katie. Any last comments from our presenters before we sign off here?
just thanks to everybody for being here and listening to our presentation. And again, if you have feedback for ClimateData.ca, please let us know. We try to be as user-driven as we possibly can. So any suggestions that you have, please let the support desk know, and we'll try and incorporate them into the site.
I echo Elaine's comments and thanks.
So with that, thank you very much. Merci beaucoup tout le monde. Have a really great day. Bye. Thank you.